These are notes for Lesson 2, Introducing Proportional Relationships with Tables. And that's the key here, is the use of tables. So in this first problem, what the authors want students to see is that there are a couple different ways to go from one column to the other column, or to go from one row to another row. And in one case, you can use what's called the scale factor. And this is what they worked towards for Unit 1, is understanding scale factor. So this 2 here times 2, that's a scale factor of 2. So 5 times 2 is 10. 60 times 2 is 120. So scale factors go from one property, or property number 1, and use a factor to get to another value for property number 1, so that it stays within the property. And then they also have to do the same thing for the second property. So it's property number 2, using that same factor, in this case 2, to get a different value within that same property. So this is cases to cases, 5 cases to 10 cases, and this is rows to rows, 60 rows to 120 rows. And notice that for scale factor, there are several different scale factors that you can use throughout this problem. Times 3, times 5, times 2. So scale factor, to use a scale factor, means that both properties, cases and rows, change in the same way using multiplication. So you're changing one property using a factor, and then you're going to change the second property in that same way using that same factor. Now that's different than using what's called the constant of proportionality, and this is the big push in Unit 2, is to move towards an understanding of the constant of proportionality. So rather than go from row to row, 1 times 3, 12 times 3, you could go from column to column. So the number of cases, how many rows are in each case? Well, there are 12. That means every time you have a certain number of cases, you multiply that times 12 to get the number of rows. So 5 times 12, 10 times 12. So it's just one factor when multiplying from x to y. So y is going to equal 12 times x. So the factor is constant. So 12 times 12 times 12 times 12. That's why they call it the constant of proportionality. And it's going to help identify what are proportional relationships. If there is a constant of proportionality, that is one element of showing that it is a proportional relationship. And so notice in this case, you're moving from one property, cases, to the other property, rows. You're going from one property, cases, to the other property, rows. And you can use the same factor throughout. It's not changing the scale factors. You change factors. Constant proportionality, you maintain the same factor. All right, this is activity 2, so more of using tables. So now we're going to see that some differences arise. So it says a recipe that 2 cups of dry ice will serve 6 people. So complete the table. So how many people will 10 cups of dry rice, did I say dry ice? How many people will 10 cups of rice serve? Well, the number of people that get served is 2 times the number of cups of rice. So that's an important point to understand. So the y column is, 3 times. The number of people served is 3 times the number of cups of rice that you have. So the y column is 3 times the x column. So 2 times 3 is 6. 3 times 3 is 9. 10 times 3 is 30. And then we're going to get down here where you know the value of the number of people. So how many cups of rice do you need? But first of all, you can also use scale factors. So 2 times 5 is 10. If you want to go from the number of cups of rice of 2, multiply it by 5, you can get to 10. 6, multiply it by 5, you get to 30. Harder to go to 3. That would be times 3 halves, and more than likely you're not going to do that. To get to 15 and 45, I rewrote this 3 and 9 down here right next to it. So I could show you that 9 times 5 is 45 and 3 times 5 is 15. It's just really coincidence, I think, that the scale factors are the same. So scale factors, generally, you have different scale factors for different rows, depending on what you're doing. But notice that if you go from one column to the other column, that's using the constant of proportionality. That is the same factor, times 3, times 3, times 3. That's the constant of proportionality. Now, what if they tell you the number of people that you have? Well, it only makes sense that if I multiply the number of cups of rice by 3 to figure out the number of people, if I divide the number of people by 3, that's going to tell me how many cups of rice I need. So 45 divided by 3 is equal to 15. And here's a little drawing over here. If you want to get to 1 cup of rice, I don't think they ask you to do that anywhere. But if you want to get to 1 cup of rice, you can look at it as a cup of rice for 3 people, another cup of rice for 3 more people. So these are the 2 cups of rice for 6 people. But then if you simplify that, 1 cup of rice for 3 people. So it's 3 people for 1 cup of rice. That is the constant of proportionality. And so I'm going to start saying this sentence in words and then moving it to mathematical language. So we're going to do this over and over and over again, and you'll see how this works as we go through the unit. So the number of people is 3 times the cups of rice. So the number of people is 3 times the cups of rice. So y, by convention, we always put y in the right column and x in the left column. So y is 3 times x. So this value y is 3 times that value x. So now we can change that to mathematical terms. So y is 3 times x. So y equals 3 times x. And what that tells you is that the ratio of y to x is 3 to 1. So y is 3, x is 1. So y is 3 times x, or 3 times 1 is that 3. So that's the constant of proportionality. And we're going to start making a move towards using mathematical terms based on the language, and also getting used to writing the constant proportionality as the ratio of y, whatever in the y column, to whatever is in the x column. So it's starting to move towards the essence of the unit. Problem number 2, it's more interesting because now the scale factors really don't help at all in this problem. So the recipe says that 6 spring rolls will serve 3 people, complete the table. So if you have 6 spring rolls, you can serve 3 people. You have 30 spring rolls, you can serve half as many people as you have spring rolls, so you can serve 15 people. If you have 40 spring rolls, you can serve 20 people. So notice that I can use a constant of proportionality, which is 1/2, but the scale factors are not easy to come by. To go from 6 to 30, it is a scale factor of 5. 6 times 5 is 30. 3 times 5 is 15. But to go from 6 to 40 or 30 to 40, there's no easy scale factor to use. To go from 3 to 28, no easy scale factor. 15 to 28, 20 to 28, there's nothing that really works easily. But you can always use the constant of proportionality. That's the point. It's going to be much easier as you move forward to focus on and use the constant of proportionality. So the number of people is half as many. You can serve half as many people based on the number of spring rolls that you have. So if 28 people show up for your party, how many spring rolls do you need? Well, you need twice as many spring rolls as there are people. So that is 28 times 2 to go from the number of people to the number of spring rolls, to go from the y column to the x column. This is the reciprocal of 1/2. So if you use 1/2 to go from the left to the right, you're going to use the reciprocal of 1/2 to go from the right to the left. And the reciprocal is another word for that, is the multiplicative inverse, because 1/2 times 2 over 1, or times 2, is equal to 1. That is called the multiplicative inverse. And finally, Let's use the language down here and then write the equation. So y is 1/2 the number of units of x. So y, right here, is half the number of units, 6 units of x. So 3 is 1/2 of 6. So y divided by x equals 1/2, because y is 1/2 of the number of units of x. So if you take y and you divide it by x, you get 1/2, and that's the same as y over x, or y divided by x. So y divided by x is 3 over 6, which is the same as 1/2. So y over x is equal to 1/2, and then you can just write in mathematical terms this phrase right here: y is 1/2 the number of units of x, y is 1/2 x, y equals 1/2 x. This is going to be cumbersome in the beginning, but as we do it more and more and more, it gets easier and easier. All right, this is activity 3, making bread dough. And I'm going to go right away to the next page. I want to show you how you can come up with this constant proportionality right here of 10/8. So it's 10/8, 10/8, 10/8. And notice if you go in the opposite direction, you're going to use the reciprocal, 8/10. But first of all, let's focus on that 10/8, and then we'll come back and go through a little bit of this arithmetic. So 8 times what number equals 10? Let's just go back for a second. 8 times what factor equals 10? Well, I told you it's 10/8, but let's pretend we don't know that just yet. So 8 times what equals 10? And there's going to be several ways to figure this out, but right now let's just reason through it. Well, 8 times some number equals 10. One of the things I want to do, if you look at this in 2 steps, one of the things I want to do is I want to get rid of this 8. There's not an 8 over here. I want to get rid of it. So how can I get rid of it? I can divide by 8. So I'm going to get rid of the 8. 8 times 1/8 is equal to 1. 8 divided by 8 equals 1. Okay, that's the first step. The second step is I want to get the 10 on the right side. So I'm going to just multiply by 10, because 1 times 10 is equal to 10. All right, so this is one step as you divide by 8. The second step is you multiply by 10. So now let's put it together as one step, one problem. So multiplying by 10/8 is the same as these 2 steps. And so it's 8 times 10/8. So 8 divided by 8. And I always tell students when they're working with fractions, divide first. It makes the number smaller, easier to work with, and then multiply by the numerator. You're usually taught to multiply by the numerator first, but now you get this big number and then you have to divide. A lot easier to divide first. So 8 divided by 8 is 1. 1 times 10 is 10. So again, and you get to the shortcut pretty soon, but teachers don't push this too quickly. They have to work through these steps and practice them so that students really truly understand what's going on. But 8 divided by 8 is 1. These 8s cancel. And so people start using that language and forgetting it, begins to lose context. It's really 8 divided by 8 is 1, and 1 times 10 is 10. So over here, 10 is 10/8 the number of units of 8. I'm going to show you a drawing of that in just a second, but read that again. It's cumbersome. 10 is 10/8 the number of units of 8. So 10 is 10/8 times 8. So right here, 10 is 10/8 times 8. So now we can get to this over here. 10 equals 10/8 of 8. Again, cumbersome. And finally, the equation y is equal to 10/8 x. So that 10/8 is the constant of proportionality. This stuff you just have to go over and over and over and keep saying it and try to understand it. You're going to get lots of practice in this. But let's look at a picture of this that will help. A drawing. And this is a drawing of that same thing. So I'm going to draw a number line, divide into 10 equal parts, And I'm going to identify the eights. The eight's right here. So if I divide that 8 by 8, it's going to take me down to this 1 unit right here. So that unit right there is 1/8. The space right here is 1/8 of 8. So 8 divided by 8 is this 1. And so down here, that 1 is 1/8 of 8. You need 8 of these pieces. 1, 2, 3, 4, 5, 6, 7, 8 to get out to 8. 2 is equal to 2/8 of 8. This is 1/8. This is 2/8 of 8 is equal to this 2. 3 is 3/8 of 8. 4 is 4/8 of 8. 5 is 5/8 of 8. 6 is 6/8 of 8. 7 is 7/8 of 8. 8 is 8/8 of 8. It's the whole thing. Now this is why I want to do this. What happens when you go beyond the 8? So now I'm going to go one of these units beyond this 8. So that's 9 of these fragments, of these sections. Well, 9 of them is 9/8. I have 9 of these pieces. So this point right here is 9/8. And now 10/8 is I have 10 of these pieces. So this is 8 of them, 9 of them, 10 of them. But what's the size of each of these fragments? Each of those fragments is 1/8. And now I have 10 of them. That's 10/8. All right, keep going. This is the same drawing. This is 10/8. So 8 times 10/8. I'm not saying right. 10/8 of 8 is the same as 10/8 times 8. So remember, that's taking 8, dividing it by 8, and multiplying it by 10. So taking this 8, dividing it by 8, and then multiplying it by 10. So y is equal to 10/8 of x. It's the constant of proportionality. This gets tough, and if your comfort level with fractions is not very good, it's going to take a while. You have to think through it, make these drawings, do whatever you can. All right. You can draw a double number line to prove to yourself that 10/8 is the same as 5/4. So if you divide 10 in half, you get to 5. If you divide 8 in half, it gets to 4. So 10/8 does equal 5/4. And I also drew the fractions down here just for fun. This is 1/10 of 10. This is 1 is 10/10. But here, this tick mark right here is actually 8/10. It's 1/10 of 8, which is equal to 8/10. This is 16/10, 24, 32, 40, up to 80/10, which is the same as 8. All right, so if we go back to here, so let's use, this stuff's tough. Let's use some of this, the constant proportionality. I worked through some of this math. So how many cups of flour do they use with 20 tablespoons of honey? Well, 20 tablespoons of honey use 10/8 of, so y is equal to 10/8 of the value of x. So x is 20. What's 10/8 of 20? 20, that's 20 divided by 8. That's 28 times 10. And I'm going to go through some steps. I'm only going to do this a couple times, but all the rest of it's pretty much the same. I'm going to separate 28 into 16/8 because that's 2 plus 4 more 8s. And that's times 10. So 16/8 is equal to 2, and 4/8 is 1/2 times 10. Well, 2 1/2 is the same as 2 5/10. Times 10 gets you to 25. So rather than just plug things into a calculator, I'm trying to get students to go through some of this arithmetic just to practice using fractions. Let's do the same thing with 10/8 of 13. So remember, you're going to divide that 13 by 8 first. So that's 13/8 times that 10 times 10. Now 13/8 you can rewrite as 8/8 plus 4/8 plus 1/8. So I'm looking ahead and I'm thinking, okay, I know what 8/8 is. I know what 4/8 is, and I have 1 more eighth to deal with. Each one of these gets multiplied by 10. So that's 1 1/2. 8/8 plus 4/8 is 1 1/2 plus 1/8. Both of those get multiplied by 10. Well, 1 1/2 times 10, that's 1 5/10 times 10, plus 1/8 times 10. 1 1/2 times 10 is 15. And 1/8 times 10 is 10/8. 10/8 is the same as 8/8 plus 2/8 equals 15, 16, and 2/8 is 1/4. Yeah, this stuff is tough. If you just keep skipping over it, though, you're not going to learn. Kids are not going to learn it. So you have to fight through it, keep writing this stuff out. Y is to x, going from y to x, and going from x to y. Oh, this is the last. Okay, this is the 20 going to 16. So if you're going to go in the opposite direction, if you're given the amount of flour, the amount of honey is going to be 8/10 the amount of flour. It is the reciprocal. You multiply by the reciprocal, which is the same. It's also called the multiplicative inverse. So 20 times 8/10 is equal to 20/10. 20 divided by 10 times 8. Well, 20 divided by 10 is 2. 2 times 8 is 16. But now if you turn it around and you multiply 16 times 10/8, that's what I'm doing here. 16 times 10/8, you get 16/8 times 10. So that's 16 divided by 8 is 2. Times 10 is 20. So you get that 20 back. So here's the 16 divided by 8 right here. 16 divided by 8 is 2. Times that 10 times that 10. And the language, the units of flour is 10/8 times the units of honey. So 10/8 is the same as y divided by x. 10 divided by 8, that 10 divided by 8. And so for every 8 tablespoons of honey, you use 10 cups of flour. So the amount of flour that you use, y, is 10/8 the amount of honey that you use. So it's y is equal to 10/8 times the amount of honey, which is 8. This is activity 4, called quarters and dimes. And I go through the calculations for this activity on the next page. Actually, I do it 4 different ways. Times 10/4, times 5/2, times 2 1/2, and times 2 1/2. And these are all, 4 of these are basically the same number. It's just doing it 4 different ways. But let's look at the constant of proportionality first. So if you look at the table, I have 4 quarters. If you have 4 quarters, then that is equal to 10 dimes. And so if you use this idea of multiplying the 4 times 10/4, remember you're getting rid of the 4, so you're dividing by 4 and you're multiplying by 10. So 4 times 10/4 does equal 10. So that tells you that the 10/4 is the constant of proportionality. Now 10/4 simplifies to 5/2. So right down here. So 10/4 is equal to 5/2. So 1/4 is equal to 2 1/2 dimes. So 5/2 dimes. So that's like having 2 dimes and 1 nickel, and that makes sense. You all know that 1/4 is 2 dimes and 1 nickel. So if you have 4 quarters, then you have 2 1/2 times that, or 5/2 times that, and that is equal to 10. If you have 6 quarters, then you have 5/2 of 6 quarters. Well, 5/2 of 6 is 6 divided by 2 is 3. 5 times 3 is 15. 15 dimes. If you have 14 quarters, then you have 5/2 of 14. Well, 5/2 of 14 is 14 divided by 2 is 7. And 5 times 7 is 35. I hope that you see that dividing first makes it a lot easier to do this calculation in your head. if you were to multiply first, you'd get 14 times 5, and I'd have to sit there and think about that and try to figure out, and then you take half of that. So it's easier to divide first. It keeps the numbers smaller. What value belongs next to the 1 in the table? Well, that is the 5/2. That's the constant of proportionality. So let's go through the language a little bit. The number of dimes is 5/2 times the number of quarters. So that means that there's a larger number of dimes, which makes more sense, or which makes sense. So dimes has to be, you have to multiply the number of quarters by a number larger than 1 to get the number of dimes. Well, dimes are equal to 5/2 times the number of quarters. So the number of dimes is equal to 5/2 times the number of quarters. So that's the same as y equals 5/2 x. So you can use this language to get to this equation, y equals 5/2 x. And if the number of dimes is equal to 5/2 times the number of quarters, means that y over x, y divided by x, is going to equal 5/2. So y divided by x, so y is the 5, x is the 2. So that's 5 dimes for every 2 quarters. Well, that makes sense. 5 dimes is 5 times 10 cents is 50 cents. And 2 quarters is 2 times 25 cents is 50 cents. So this makes sense. This ratio of 5/2 makes sense. 10/4 is equal to 5/2, so it simplifies to 5/2, and I'm going to go through that on the next page. And that is the constant of proportionality. So the number of dimes is 5/2 times the number of quarters, and that 5/2 is the constant of proportionality. 6 times 5/2, 14 times 5/2, 1 times 5/2. So that 5/2 is the constant of proportionality. Now I would suggest that students do these calculations at least more than once, and preferably do it all 4 times. This takes a lot of time. It's a lot of effort because there's a lot of thinking about fractions and how to divide things up and look at it without using a calculator. So just being able to do the mental math. So the first one. So first of all, up here, 4 times 10/4 equals 10. So this is the constant of proportionality. You can draw a little double number line here to prove to yourselves that 10/4 is in fact equal to 5/2. Half of 10 is 5, half of 4 is 2. So 10/4 equals 5/2. 10/4 equals 5/2. 2 times 5 is 10. 2 times 2 is 4. All right, so 5 times 10/4. So remember, that's the same. So that's not 5 times, 4 times 10/4. So 4 times 10/4 is divide by the 4 first. So that's 4 divided by 4, and then multiply by 10. Well, 4 divided by 4 is 1. 1 times 10 is 10. Now you're going to get the same answer all the way across because you're multiplying basically by the same number. This gets a little bit easier if you use the simplified equivalent ratio or the simplified fraction. 4 times 5/2, 4 divided by 2 times 5. Well, 4 divided by 2 is 2. 2 times 5 is 10. So just work through each of the steps and think about what you're doing. 4 times 2.5. So I'm going to use the distributive property here. 4 times 2 plus 1/2. So 4 times 2 is 8. 4 times 1/2 is 4/2. 4/2 is 2. 8 plus 2 is equal to 10. And finally, 4 times 2 and 5/10. Well, think about 4 quarters, or 4 times 25 equals 100. So 4 times 2 and 5/10 is going to equal 10. And likewise, 4 and 25/100, 4 quarters equals 1, equals $1. All right, so if you go from the 4 to the 6, so the answers for the 6 are going to be 1.5 again, 1.5 again as much as 4. So half of 4 is 2. So 1/2 of 4 is 2. 2/2 of 4 is 4. And 3/2 of 4, so a half again as much. is going to equal 6. So it's 2, 4, 6. So 3 halves of 4 equals 6. And 3 halves of, so do this on a few different numbers. What's 3 halves of 10? Well, that's 5, 10, 15. 3 halves of 10 is going to be 15. 5 is 1 half, 10 is 2 halves, 15 is 3 halves. What's 3 halves of 24? Well, 1 half of 24 is 12. 2 halves of 24 is 24. 3 halves of 24 is 36. So it's 12, 24, 36. So you can practice doing that a little bit. But for this problem, what's 3 halves of 10? 3 halves of 10 is equal to 15. 5, 10, 15. All right, so what's 6 times 10 fourths? Let's use the constant proportionality times 6. So divide by the 4 first. 6 fourths times 10. Well, what's 6 fourths? And you have a little bit of trouble looking at that. Just divide it up, separate it out into 4 fourths plus 2 fourths. Now this becomes easy. And those both have to get multiplied by 10, by the way. So 4 fourths is 1. 2 fourths is 1 half. So 10 times 1 and 1 half is equal to 10 times 1 is 10. And 10 times 1 half is 10 halves. So 10 plus 5 is 15. So I'm basically just playing around with the numbers a little bit, using the distributive property, trying to help students see different ways of looking at these problems. 6 times 5 halves is equal to 6 halves. So divide the 6 by 2 times 5. Well, 6 divided by 2 is 3. 3 times 5 is 15. So this is probably the easiest one. So to multiply by 5 halves, I think, is all the way down. Seems to be the easiest way to do this. 6 times 2 and a half, separate out the 2 plus 1 half. 6 times 2 is 12. 6 times 1 half, what's 1 half of 6? That's 3. 12 plus 3 is 15. And finally, 6 times 2 and a half, you work through this, you're going to get 15. 6 times 25 is 150. Think about 6 quarters. 6 quarters is equal to 150 cents, or $1.50. All right, 14. 14 times 10 fourths gets a little bit harder. So divide the 14 by 4 first. And so 14 fourths is the same as 12 fourths, and you know what that is, plus 2 fourths. And you have to multiply both of those by that 10 right there. So 12 fourths is the same as 3. 12 divided by 4 is 3. 2 fourths is 1 half. Well, 10 times 3 is 30. That's right here. And 1 half of 10 is 5. 30 plus 5 is that 35. And if you write the 3 plus 1 and a half here, 3 and a half times 10, another way to see the 10 times 3 is 30, and the 10 times 1 half is 5. All right, and this seems to be the easiest one, 14 times 5 halves. Well, what's half of 14? 14 halves is 7, and then 5 times 7 is that 35. Again, this one seems to be the easiest. 14 times 2 and a half, use the distributive property, you get 14 times 28, and half of 14 is 7, and so 28 plus 7 is 35. All right, and 14 times 2 and 5 tenths. 10 times 2 and a half, we did that before, we did that up here. So 10 times 2 and a half is 25. And 4 times 2 and a half, actually we did that one up here. 4 times 2 and a half is 10. 25 plus 10 is 35. So I'm going through this a little bit faster. So 1. So you guys just work through that on your own. All right. So this is activity 4. So problem number 1. These are long, actually this problem is just filling in the blanks a little bit, but I wanted to go through some of the math over here. Just, you have to practice this stuff. You have to go through it and make sure that you understand how to get these answers. So there's cups of milk, and there are tablespoons of chocolate syrup. So 2 cups of milk, for every 2 cups of milk, you need 3 tablespoons of chocolate syrup. So I like to talk about these as units. For 2 units of milk, you need 3 units of syrup. So that way the 3/2 it just makes more sense to me when you do it that way. So 2 times 3/2, if you divide by 2 first, that's the first step. 2 divided by 2 is 1. And then you're going to multiply that times 3. So 2 divided by 2 is 1. And multiply by this 3. 3 times 1 is 3. So 2 times 3/2, that is the constant of proportionality, equals 3. 8 times 3/2. Well, 1/2 of 8 is 4. 2/2 of 8 is 8. 3/2 of 8 is 12. So it's 4, 8, 12. This one is 1/2, 1, 3/2. So 3/2 of 1 is 3/2. And that's the same as y divided by x. If you go up here to the y, divide that by the x, that equals 3/2. So that is the constant of proportionality. And if you're given 10, to get to the 15, it's 3/2 of 10. So divide 10 into half, that's 5. 2/2 is 10. 3/2 are 15. 10 divided by 2 is 5. 3 times that 5 is 15. And I wrote that out here, over here. So each 1/2 of 8, you need 3 of those halves. 3 4s is equal to 12. 10 times 3/2, each 5 is 1/2 of 10. You need 3 of those halves. So 3 times 5 is equal to 15. The chocolate syrup is 3/2 times the cups of milk. So the syrup, S, equals 3/2 milk, M. So y is equal to 3/2 x. So the amount of syrup you use, the number of units of syrup you use, is more than the number of units of milk. It's 3/2 of the number of units of milk. So the constant of proportionality is 3/2. The proportional relationship is cups of milk and tablespoons of chocolate syrup. The scale factor that they use is 4 up here. But you would use different scale factors. This would be 1/2. 2 times 1/2 is 1. 3 times 1/2 is 3/2. This would be a scale factor of 5. 2 times 5 is 10. 3 times 5 is 15. Notice it's different scale factors, but it's the same constant of proportionality. And so the units for the constant of proportionality are tablespoons of chocolate syrup per a cup of milk, or per 1 cup of milk. Tablespoons of chocolate syrup. It just says units. So it's the unit is a tablespoon. So it's 3 tablespoons per 2 cups. I'm not sure which they want in this case, but that's not a choice down here. So it's tablespoons of chocolate syrup per a cup of milk. 3 tablespoons, 2 cups of milk. All right, that's problem number 1. Problem number 2. Certain shade of pink. Now this is a mixture of red paint and white paint. So the white paint, the X, is 1 cup. The red paint down here is how much, is what fraction of white paint. And down here, you know it's a smaller amount because you go from 7 cups of white paint and you use 3 cups of red paint. So the constant proportionality is that 3 divided by 7. So it's 7 times 3/7. Remember, you want to divide by the 7 and multiply by the 3 to get 3. So y over x is this 3, x is the 7. So the constant of proportionality, which is y divided by x, is 3/7. So what is the constant of proportionality? It is that 3/7. So in words, the cups of red paint is 3/7 times the cups of white paint. So think about that and say it again. The cups of red paint is 3/7, it's a fraction, times the cups of white paint. So if you just write that with math symbols now, the red paint is equal to 3/7 of the white paint. And use y and x. Y is equal to 3/7 x. So y divided by x is equal to 3 divided by 7, which is equal to 3/7. So y is 3/7. It's that fraction of x. It says here, note that the amount of red paint is less than the amount of white paint because it's a fraction. R is a proper fraction, by the way, of white paint. So our red paint is 3/7 of the white paint. 3/7 times the white paint. The words just seem to kind of all mesh together and it just becomes words. You have to slowly think through this, or students have to slowly think through this. Problem number 3. This is a hard problem. This is from Unit 1, Lesson 12. And they tell you that there's a map of a park. It's 4 inches along the length, so 4 inches in the length and 6 inches in the width. And it uses a scale of 1 inch for every 30 miles. So I go 1 inch, that's 30 miles. 2 inches, that's another 30 miles. 3 inches, that's another 30 miles. 4 inches, that's another 30 miles. So this length is going to be 4 times 4 inches times that 30 miles. It's going to be 120 miles. The 6 inches for the width is going to be 6 times that 30 miles, or 180 miles. And they want to know, what is the actual area of the park? Well, if you know the length in miles and the width in miles, you can just multiply those together. Get out a little calculator. 120 times 180 is going to give you 21,600 square miles. But that is too easy. You have to work a little bit more than that. You could get away with just doing that. But think about this for a second. Consider that the map is equal to 24 square inches. Each square inch is equal to 30 times 30, or 900 square miles. So think about that again. Each square inch is equal to 900 square miles because each inch is 30 miles. So 30 times 30 is 900 square miles. Well, how many square inches do you have? You have 24. So then that's 24 times that 900 square miles for each inch. So 24 times 900 does in fact equal. And to do this stuff mentally, I would look at this as 1,000 minus 100. So 24 times 1,000 is 24,000, and subtract the 24 times 100, which is 2,400 or 2,400. And you can probably do that in your head. It's 21,600 square miles, same as up here. And finally, I would have students play around with the numbers a little bit, play around with the factors. Factors of 120 are 3 times 4 times 10. The factors of 180 are 3 times 6 times 10. So here's the 10 times 10, and here's the 3 times 3. Remember, there's a 900 in here somewhere. So 3 times 3 is 9. 4 times 6 is the 24. There's the 24 right there. And 10 times 10 is 100. There's the 100 right there. So move the 100 over here. 9 times 100 is 900 times 24 again equals that 21,600 square miles. So if students try to do these problems in a variety of different ways, or take your time and think about it, they will build strength mathematically. All right, this is problem number 3, the B part. This gets pretty tough. They say that they want to change the scale of the map so that it covers 6 square inches rather than 24 square inches, because they want to put it into a brochure. Now what you're going to see in this case is that there's a distinction between scale factor and scale. So the scale factor is going to end up being 1/2, but this change in the scale is going to be the reciprocal of 1/2, or 2 times. I'm going to show you why that is in just a moment. All right, so if you're going from 24 inches to 6 square inches, 6 out of 24 is 1/4. So 1/4 of 24 is equal to the 6 square inches. So you take 1/4 of this map, so that's just this area right here. That means that what you're doing is taking half of 6. So this is 3 now, so the scale factor is 1/2. 1/2 of 6 is 3, and 1/2 of 4 is 2 to get to this 1/4. A couple ways to get at that. easiest way probably is to realize that it's 1/4 and divide this into 4 equal parts and write down the width and the length. All right, the scale factor is 1/2 to get to an area, 1/4 the size. So 1/2 of 6 is 3, 1/2 of 4 is 2. But notice what you're doing to get to the area. What you're going to do is multiply 3 times 2, but that's 1/2 of 6 times 1/2 of 4. 1/2 times 1/2 is 1/4 of 24 equals 6 square inches. So what you multiply by is actually the square of the scale factor. So you multiply by the square of 1/2 because it's 1/2. I did show. Oh, that's later. Oh, I can use this. You multiply by the square of 1/2 because 1/2 times 1/2 is 1/4. So the scale factor for the map is 1/2. So each side is multiplied by 1/2, but then the scale will be doubled. So in that 1 inch, that 1 inch is no longer equal to 30 miles. It's actually equal to 60 miles. It's equal to twice as many miles in that 1 inch. Because now you just have 2 inches. That 2 inches has to equal 120 miles. So 2 times 30 miles equals 60 miles per inch, and there's 2 inches. So 2 times that 60 miles per inch is equal to 120 miles. So it's 2 inches times 60 miles for each of these inches equals 120 miles. And 3 inches times 60 miles for each inch. Because now you still have to get that 180 miles in these 3 inches. So that means that each inch is equal to 60 miles. So 3 inches times 60 miles per inch. So you're doubling the scale. The scale factor was 1/2. You multiply the scale by the reciprocal of 1/2. You double the scale because you're getting twice as many miles in 1 inch. So 3 inches times 60 miles per inch equals 180 miles. So this is 120 miles times 180 miles, or by 180 miles. So this is the correct measurements for the park. So the scale is 1 inch for 60 miles. So the scale is twice as many units per inch. 1 inch for 60 miles. This is a tough problem. Probably, I think, maybe the toughest problem, kind of problem, in the entire 7th grade. And they give that to you in the first unit. All right, so Noah drew a scale copy of polygon P and labeled it polygon Q. This is polygon Q. I kind of covered it up there. And so the change in the area is the square of the scale factor. So he's going to take polygon P, which is actually the small one right here, and that's going to be scaled up. And they want to know if the area of polygon P is 5 square units, right here, 1, 2, 3, 4, 5. What's the scale factor? What scale factor did Noah apply to polygon P to create polygon Q? Well, the area of, and I'll get to this in just a second, but the area of this, of polygon Q is 5 of these 9 unit pieces. So 9 squares, 9 squares, 9 squares, 9 squares, and 9 squares. You could look at it as 9 times 6 this way, which equals 54, and then subtract this 9, or just realize that it's these 5 times 9, or 9 times 5 equals 45. Either way, you get 45. Now realize that for area, you're going to use the square of the scale factor. The reason you use the square of the scale factor is over here. So the change in area is the square of the scale factor because the area is the length times the width. But if you multiply it by a scale factor, it's the scale factor times the length times the scale factor times the width. Well, scale factor times scale factor is the square of the scale factor, and that's times the length times the width. Well, the length times the width is the 5 square units. That's this amount right here. But that gets multiplied by, 5 gets multiplied by what value to get to 45? So 5 times the square of the scale factor, this is why this stuff is hard. 5 times the square of the scale factor is 45. So what's the square of the scale factor? It is 9. 5 times 9 is equal to 45, or 45 divided by this 5 is that 9. And so what number times itself equals 9? That's the number that gets squared. Well, 3 times 3 equals 9. So that makes the scale factor 3. So if you went back over here, this would be 3 times the length times 3 times the width. The length times the width is equal to 5. And 3 times 3 is 9. 9 times 5 is 45. So the scale factor, the answer to the question, is what scale factor did Noah apply? He applied a scale factor of 3. So it's 3 times this way. 1, 2, 3. And 3 times this way. It's 3 units is 1. 3 units is 2. 3 units is 3. And notice that this 1 unit right here is right in the center. It's 3 of those units to get to here. All right, again, this is a tough problem. All right, problem number 5. Select all the ratios that are equivalent to each other. So you just have to look at these and try to figure out which ones go together. So I write them as 4/7 this way. So this is a ratio of 4 to 7. If I multiply both the top value and the bottom value times 4, so 4 times 4 is 16, 7 times 4 is 28. So these are equivalent ratios, and that's right here, C. So A and C are the same, or are equivalent. And then 4/7, or a ratio of 4 to 7 times 5. 4 times 5 is 20. 7 times 5 is 35. And so E also fits in as an equivalent ratio. The 2 to 3 and the 8 to 15 don't fit anywhere. 2 times 4 is 8, but 2 times 7 is 14, not 15. Go to the 2, half of 4 is 2, half of 7 is 3.5, so this one doesn't fit. 2 times 4 is 8, 3 times 4 is 12, so those two don't go together. So the only 3 that go together are A, C, and E. They are all equivalent ratios to 4/7. 4/7, 16 28, and 4 to 7, 16 to 28, and 20 to 35.